right, let's get started. Good afternoon. Welcome to Techlandia, the official podcast of the Technology Association of Oregon. I'm your host today, Erik Stromquist, a TAO board member, and today we're coming to you live from the Worldwide ESG Conference here in Portland. At this conference, leaders come from around the globe and are gathering to talk about the future of sustainability, resilience, and responsible innovation. Here at TAO, we're deeply committed to accelerating that future. That's why we're launching the new Sustainability Alliance in Oregon, a cross-sector collaboration designed to help companies build cleaner, more resilient, and more equitable systems for the decades ahead. Along those lines, I'm super thrilled to introduce our guest today, Adib Naslé, CEO and founder of Xendee, a company at the forefront of designing and operating the next generation of microgrids and distributed energy systems. Adib, let's get started at the beginning. Tell us your founder story, how you got here.
Well, Erik, the path was unconventional, I would say. I've been in the power system engineering world most of my adult life, and I was very intrigued with the whole opportunity space around these complex on-site energy systems, and felt that a few pieces needed to come together to really unlock the potential and opportunity this new technology, microgrids, offers, and teamed up with my co-founder, Scott Mitchell, who had been a Microsoft Most Valuable Professional for over a decade and brought a lot of talent on the software development side. And then Michael Stadler, our co-founder and chief technology officer, who had been leading the grid integration and all the microgrid research team at Lawrence Berkeley National Labs. And the fundamental goal was to really make the return on investment and the speed to profitability with distributed energy resource assets as quickly and as efficiently as possible. And the path that we decided to take was to address the bankability of the projects from a financing perspective, from an emissions perspective, and from a resiliency perspective. And we started developing software that we felt was missing in the industry to be the glue or the operating system that brought an end-to-end approach to this space and the opportunity itself. And we started the company middle of 2018 and have been growing steadily since, with a lot of success and wins behind us. And I can say with confidence that we're considered the gold standard when it comes to designing and operation of microgrids and complex DERs.
So we're going to get into a lot of, interesting stuff about your company and Xendee. But what did, before you guys joined or started, what did the industry look like? What was the climate like before you guys decided to work on this thesis together?
It was very disjointed, and we felt complicated. And whenever there is, I would say, lack of continuity and complexity, we felt that brought a lot of fear and uncertainty into the hearts and minds of both the investors who are putting money at risk and the end users who are being promised a certain set of outcomes and expectations by making investments in on-site power plants. So we saw different approaches to how you plan and design these systems, a cobbled together symphony of different types of software and spreadsheets, and then a whole different approach to how you actually operate and control these technologies. And there was a lot of money going into the control side at that time. There was a lot of interest in controlling assets, but we felt that the right place to start was actually on the planning and design side initially, and then form the addressable market for controls to go in. And then the controls, we felt it was critical that there were not these traditional rules-based approaches, but an adaptive, forward-looking approach that we called model predictive control.
I mean, that's super interesting. Without disclosing too much confidential information, but who are your customers? Who is finding value in this right now? And I'm sure this is a moving target as you guys expand, but can you give us a list of customers that are finding value in your solution?
Yeah, I mean, we have customers on our website under the customer list that we can disclose, but I can say openly, you'll find our team of technology behind the planning, design, and operation of microgrid projects worldwide that are renowned. We're supporting, for example, Lancium on the OpenAI Stargate 1 data center, the Kingdom of Saudi Arabia on the NEOM Sustainable City, And we also supported the Southern Pennsylvania Resilience Corridor that was developed after Hurricane Sandy. We're the software of record for the New York Power Authority. So from Walmart to Cummins and Mainspring and Eaton and all the major players in the space, they're on our platform. And they're using our technology to deliver resilience, reliability, and sustainability for the CNI industry, whether it's the data centers to manufacturing, hospitals, and federal facilities and critical infrastructure.
That's super impressive. Thanks for sharing that. Okay, I think the next section, we really want to get into what everybody's been hearing about and why the technology you're developing matters so much now. And the topic is the grid capacity crunch. So, everybody keeps hearing about rising electricity demand, AI, data centers, EVs, all of this stuff. I'd love to hear you dissect for us what's really going on out there. Talk about the grid capacity, how your organization helps navigate that, and how you see the market evolving to address this grid capacity, and how serious is it really? Is it overhyped? Is it true? Or is it something that's a big nothing burger? I'm sure our listeners would love to hear your take on this.
Sure. Well, I can talk first from the business side or from the physics side. There's some physical realities, and then there's the economics. So, which do you prefer I start with first?
Well, I think the physics side will give us the background to get
Okay,
into economic reality. So please share your wisdom with us there.
sure. So, on the physics side, when we look at large load interconnects, what we've noticed is they are coalescing around specific geographies. And this inherently creates challenges for the public grid, or I'll call them macro grid. So imagine you have 5 gigawatt data centers all in the same zip code. Okay.
Mhm,
They're all sensing, predicting what is going to be happening with the weather, with what they're sensing through their SCADA systems on the grid. So they're all going to see and sense similar things at the exact same time, which then results in them all disconnecting potentially at the same exact time. 5 gigawatts of load just disappearing instantaneously off of the grid is not something that the grid was built to handle. It will collapse. Think of it as a tug of war. You got two sides pulling. You want each to be as even as possible. If one side just lets go of the rope, everything, people fall and the
mhm,
grid falls. We call it, you have frequency and voltage that are really the foundation heartbeats of the system. And those are going to go in the wrong direction very, very rapidly. So those are the physics, just from a very high level, that large loads inherently introduce into the macro grid. And when they start coalescing around the same area, that
mhm,
problem just exasperates. And these are mission critical facilities, which means they will disconnect. They cannot have interruption in their operations because there's either a lot of money or human life and safety or some mission critical process at stake that a lot of dollars are riding behind. So the minute they sniff even the slightest possible, problem, they're going to disconnect. How do you disconnect 5 gigs, 10 gigs all at the same time and not suffer the consequences of that? So the macro grid needs what I call an active suspension system. And microgrids are that active suspension system. Just like you have new cars coming out with the suspension systems, you hit a pothole, it doesn't just crash the car. You don't lose steering. You're not going to go off the road is because, it's got shock absorbers. It can handle it. With the size of loads that we are projecting and we're seeing, the grid needs shock absorbers, and microgrids provide that. So that's the overall high level physics challenge.
mhm.
Forget everything else, all the nuances behind it, but fundamentally, you got large loads that are built to disconnect and run autonomously under conditions of emergency or any sort of an outage scenario or any sort of scenario that they feel could lead to an outage. And that presents that physical challenge to the grid that was built, over 40 years to handle very different things.
Well, I mean, so what you're saying essentially is they're all going after it at the same time, and that's just not sustainable. Therefore, the rise in the microgrid is the solution, the suspension, like you say, right, to
Yeah.
help deal
Yeah.
with that.
Yeah. And
So,
the more and more large loads you have, the more and more active suspensions you need in different areas.
okay, I mean, I think I get the physics on, and so now tell me about the market dynamics for this and what the public is hearing about the situation.
Yeah. So the business side of it is time, or you could call it speed, and money. And the grid limitations are, inherent in in the space that we're seeing. It's not new news that upgrading or expanding grid infrastructure, when you look at transmission lines, substations, or distribution systems, it takes years and it's very, very expensive. And the interconnection delays obviously continue to be a challenge. I mean, there was uh, FERC Order 2023 that was supposed to translate into faster queue processing, but that has not happened. Average time remains 53 months nationally, and it's probably more like 58 months if you consider some of the flexibility built into those. And, these are timelines that are completely disconnected from the business needs of the industry. Industry's looking at 12 to 18 months, and you're being presented with 50 to 60 months. It's just not tenable. And paying for that infrastructure and its utilization still being suspect, and then without the ability to scale, right? Because it's one thing you need yesterday, it's something you need immediately today, these power gaps, and then there's what's needed in 2 to 3 years. And the grid infrastructure simply does not move at the pace it needs to with the strength of the business case it needs to. And whether it's AI data centers or critical supply chain manufacturing like chip manufacturing and other sophisticated manufacturing heavy load connections, the grid's ability to upgrade and expand itself in the costs and timeline that business needs is just not there. And then that doesn't even consider the regulatory overlay that has to be dealt with. So establishing the resilience, the reliability, and the sustainability that businesses are looking for. They need solutions that offer them the flexibility and the scalable infrastructure that matches their business case, their growth, and business outcomes that they're targeting. And when we look at microgrids, it's really a combination, a lot of flexibility around the generation, how you can generate energy, technologies around storage, a lot of flexibility in different ways you can store that energy, and the smart controls. And these can be deployed a lot faster. I mean, orders of magnitude faster than conventional grid upgrades and how the utilities move, which is in years or decades sometimes. So that infrastructure can now come online a lot faster, and then it has that flexibility to scale as demand increases.
So I asked you about like the public's perception of what's going on with these data centers and the energy use. Is this conversation now in the boardrooms of large corporations, or has it been in the boardroom for some while? Or is it now just getting elevated as critical to the operations of these major enterprises in North America and around the world?
I think what's happening is, as this entire digitization of modern society accelerates, with AI being one of the legs that's running with the speed towards that, and robotics is other, and smart infrastructure. But fundamentally, at the center of the enterprise is the IT infrastructure. And the demand is rising for low carbon energy solutions that have high capacity and reliability. And that means you have a lot of conversations happening around how to deploy and manage and operate on-site systems. Because with the ability to have generation storage and smart controls, now businesses can tailor their power plants bespokely to meet their needs around not only the timeline they need, but also what sort of resilience they need, what sort of business outcomes they have to deliver on, and be able to do it in the time and speed with a sophistication that their investors and the board and the executive team are building their strategy around. I mean, the future isn't chip constrained, it's energy constrained.
I know.
So
It's crazy.
energy is the bottleneck, and that bottleneck has to get addressed in a way that doesn't just solve the problem today, but delivers on the promises for tomorrow as well. And that means you have to have a way to reshape new infrastructure and build something that could be foundational. And microgrids really are being the topic of conversation within the decision and strategy makers is not only optional backup, but really that foundational infrastructure for the future of energy and to really address that central need for enterprise IT infrastructure as well.
That's great. That's really interesting to hear. So let's talk now about, the concept of digital twins, optimization. And, you mentioned this a lot. Kind of what is digital twins? What does it look like in practice? And then, additionally, how does your platform or and your partners determine the optimal mix of solar, storage, batteries, generators, and even emerging tech like hydrogen? And then kind of where your organization's evolving from more planning to actually operating this stuff and how your software gets involved in tailoring the solutions to the optimal mix for these microgrids for customers.
Okay, I'll try to remember all that and answer them in sequence, but please
Okay.
remind me if I missed something.
Okay.
So,
There's a lot there.
from
Sorry.
so practical application of digital twin. So I'll speak from the energy side of the application of digital twin. So the way we implement and deliver value through a digital twin is there's two important steps within a project that we leverage digital twins to really address. One is before a customer, what a large load or any sort of a energy service provider developer asks for implementation, we can actually assess the savings. So we use a digital twin to figure out the savings of the potential set of assets and a optimized adaptive control strategy. So what they can think of it as a near virtual test drive before you
Mm,
actually decide to build that car and drive it. We can actually virtually show you how it will handle, what the fuel economy is going to be, and even its crash performance if it was, to go through that highway safety test, crash tests. So
mhm.
we use it as a way to really bring a lot of confidence and a lot of conviction around the investment and the control strategy that's being proposed. So that's one. The other is when a system is operating in real time, we use the digital twin to in real time give feedback to the facility owner operator at every time step. This is how much more money you're making or saving. This is how much additional emissions you're reducing. Because you have to have that digital twin to show you what business as usual is looking like versus now with your new control strategy and your new optimized way to run the system and predict with this model predictive control how you're actually improving around what you traditionally would be doing. So this ability to compare savings in a real-time environment, the more proof points you have in reality at every step of a system's operation, the more confidence you have around the economic projections, the resiliency, and all the other benefits that these on-site cogeneration or electric-only solutions are providing. And that's a really, really powerful set of indices that are enabled through digital twins. So those are the two ways we leverage digital twins in practical terms.
So a question for you, you can showcase to the customer what things look like when you, work with you guys and enable the digital twins. Can you share an example where someone not only got what you were promising on this test drive, crash results, et cetera, and they were surprised by the outcome once they enable some of your technology where you beat their expectations on what your platform can do?
Yeah, and here's the thing: when you start using model predictive control technology that is forward-looking and adaptive, it will come up with control strategies that normally a human might not have thought of, because it's looking at so many combinations simultaneously that it can arrive at certain nuanced approaches that would escape the ability of a human to think of it. And we've when we started seeing these sorts of savings, we felt it was really important to get a set of outcomes that was actually unbiased and peer reviewed, because we can talk all we want about how great we are, but if someone unbiased actually is involved and says it and has no dog in the fight, we felt that that was going to be really important. So, with the state of California and UC San Diego, we implemented our model predictive control AI logic on top of an existing energy management system. So they
Mhm.
already were getting savings and benefits from this energy management system that they spent gobs of money on that was running their assets. And we said, we think we can deliver even more savings and more benefits if we put on this additional economic dispatch layer through our model predictive control. And they funded it, we implemented it, and this was a peer reviewed set of outcomes and 80% better savings.
Wow.
Yeah. So you can only write so many rules, so many if then, but in reality, things change constantly. Weather changes, so your renewable generation might be different, loads change, you got pricing signals. There's all sorts of variables that when you're in a lab writing a set of rules and then putting on a controller and then deploying it, there's only so much you can think of. And then once the system is running, sometimes equipment ages out. You got to replace it. You got to augment it. You want to put bigger batteries in, bigger some generation in. Every time somebody's got to come out and rewrite rules. And it's just very inefficient. But at the same time, it was leaving a lot of money on the table. We
Well,
wanted to show that,
let's
with,
dig,
with
let's dig
peer
into
review.
those. Let's dig into those market forces and incentives and rule making bodies just a little bit. I know you have a deep background working with DoD microgrids, I believe,
Yep.
and curious about what lessons from that work translated into the commercial world.
Yeah. So with the military, they're looking at three key metrics. And business is somewhat similar. I mean, you want speed, you want resilience, and you want outcomes that, you have confidence around. So there is a need for a repeatable, rapid, and resilient infrastructure. And we worked with the Department of Defense not only to enable the repeatability and the speed, but also the resilience. There's a lot of value around resilience that, whether it's a data center, or whether it's a critical manufacturing facility or hospital, or any sort of infrastructure where you just don't want to deal with losing power. And, at least in California, there's all these power safety shutoffs and they can last for hours to days sometimes. You can't just like stop business for that period of time. So resilience is quite critical, and we worked very closely with the different military branches to enable that, and then we roll that out to our commercial customers. So the commercial customers that are looking at deploying, whether it's from initial strategy perspective to planning and detailed design to operation, what actually not only they need to invest in, but then how they need to operate it. And we introduced this fight through survivability index in real-time operations, where on the dashboard in real time, it's always showing the survivability score of the
Mm.
systems, assuming you lose the grid at that instance. It gives you a view into not only how you will survive, but for how long, and how it's going to change its operational strategy for you to give you as much fight through enduring survivability as possible. And this is where the adaptability becomes critical, because under emergency situations, it could be that also some of your assets aren't available to you. You might think you have the array, but you don't. Maybe an inverter went bad. You might think you have the battery, but maybe the battery isn't really there. How do you adapt around that? And that's what our system does, actually. It's always understanding the health of the underlying infrastructure, understanding what is the status of and overall objective of the system, and adapting around any of these contingencies to come up still with an optimized operational strategy that gets you to where you need as best as it can get you, and with the physical constraints that it has around the system that it's managing. And that's just beyond rules at that point. That's really where you need AI and you need optimization and you need this forward-looking adaptive capability.
That's
So those are the
amazing.
ways we've taken kind of experiences from the mission critical DoD space and then translated it for daily benefits and outcomes for our customers worldwide.
Let's keep on that politics just for a little bit. So, like, how are things like incentives for the Inflation Reduction Act? How is that shaping microgrid economics? And then, of course, the current political landscape. Where are we at in terms of the microgrid and politics?
Yeah, I think if you're looking at the microgrid space where you're dealing with cogeneration needs, I mean, there there's certain assets that the IRA targeted, like solar panels, but when you're looking at the CNI space, it's not as exposed. The solar array is just one piece of a much bigger pie of generation technologies. So typically a CNI project has combined heat and power, which means there's some sort of natural gas generation that is also then using the exhaust heat to address anything from absorption chillers to hot water or space heating needs. And the exposure of a single asset's, I would say, tax benefits is muted compared to like residential, where a lot of the energy is assumed to be from solar or from utility scale solar projects, which are clearly impacted as well. So that CNI space, which is where we live and what we focused our technology around, we have over 27 technologies. So solar just happens to be one of them. And then when it comes to batteries, there's the incentives for batteries that are built primarily and sourced primarily in the US. And there's been a lot of innovation around long enduring batteries or long duration storage batteries. Those are actually becoming more and more attractive. And fuel cells, linear generators, those are actually they're getting those tax benefits. And those are the technologies that large loads are going to, need, and they're being modeled daily as part of a strategy. So we're not a single technology platform enabler, and that has insulated us and our customers who are in the CNI space from some of these very focused political and financial decisions by the government.
Great. So let's talk about the future of distributed energy for a minute. And I am here at an ESG event. I doubt there's many climate deniers here. So with climate events increasing, whether or not you believe that, what innovations will make microgrids more resilient in the future?
Well, I mean, from a overall, again, I was talking about the physics early on.
Mhm.
Let's also just address the environmental piece. And when I speak environmental, I think of it as in two pieces. One is the emissions. When you start throwing hundreds of megawatts or gigawatts of generation, that's a lot of carbon monoxide and I mean, it creates an air quality issue, which microgrids are very elegant in addressing because of the flexibility in the generation technologies that you can implement within a microgrid to address that. And then there's also noise pollution. So, I mean, if you're again running massive generation to address massive loads, there's the emissions, and then there's also I personally think of noise pollution as well. And again, microgrids, because of the flexibility they have in the technologies that can be implemented, provide a very sophisticated and, I would say, enduring infrastructure opportunity to address all of those in a way that has a strong business case, improves the savings, lowers the energy costs, drives sustainability, and brings independence into how a business wants to manage what is essentially a mission critical commodity, and then coordinate it with the main grid if desired. So as far as resilience goes, whenever you have, when you think of like resilient design, in circuits, we always look at distributed designs. When you look, even the internet is distributed, and that distribution or that disaggregation, the lack of centralization, is what inherently is, resilience by design. And when you have distributed energy systems like microgrids, they inherently, as a result of just the distributed nature of their architecture, enables resilience. And then you also have the redundancy, because you have the ability to have multiple generation technologies. I was involved with the power outage in New York many, many years ago, where every critical infrastructure in Manhattan had backup diesel generators, but they had the fuel tanks in the basement and the generators up top on the roofs because, aesthetics and so forth. And guess what gets the fuel from the fuel tank in the basement to the generator up top? Electricity. So when you don't have electricity, you don't have those generators running, right? So,
Jeez. All right.
um, when you look at how you can address the resiliency piece, the more distributed resources you have with different technologies, the better. Because if that happens, then maybe you have a different type of fuel input. It might be solar, it might be natural gas, it might be something else, right? But you don't have vulnerability to a single supply chain. You have multiple inputs, and if one fails, then you have another. Almost like, you want to have more than one engine on an airplane. So you want to have multiple opportunities to generate and store energy that are disconnected from one singular supply chain. And microgrids provide that as well, where you have that diversity of fuel inputs, you have the diversity of technologies that can generate for you, and you have diversity of technologies that can store, and then you can control all of these. And that is how you build resilient infrastructure.
That's great. As we head towards the final segment here, it's okay with you. I want to do a lightning round, just to pop off some
Okay.
questions, and then you just respond what first thing that comes to your mind, and then we'll close up here pretty soon. So here's the lightning questions. The most overrated energy technology. What do you think?
I would say most overrated energy. I would say 100% renewable data centers by 2030.
Okay. Don't
I
forget,
mean,
I'm at an ESG conference. I'll take note of that.
yeah, yeah. I
Um,
mean, you still need natural gas and gen sets for firm power. There needs to be pairing with batteries and other DER technologies to support response times and islanded operations and redundancy and so forth. So thinking you're going to run, on 100% solar battery data center for AI, that's a tough one.
okay, most underrated energy technology.
Most underrated. I don't know if anybody really underrates energy technology, but maybe grid interactive backup gen sets or
All right.
uh,
I don't know
yeah,
exactly what that
yeah.
means, but we'll take it down. Okay.
Well, there you got these backup assets that can actually be leveraged to support the grid.
Mhm.
But there's this conflict because the utilities prefer to have peaker plant revenues, and then you have these backup gensets that are just sitting there most of the time, right? Not doing much. That they could be fired up and support the grid. But you could also say maybe virtual power plants in some way
Okay.
maybe are have been underrated.
All right. One misconception about microgrids you wish more people understood.
That their complexity that their complexity brings doubt into their outcomes. That complexity actually delivers a level of sophistication and tailoring that is what a customer would want to make sure that they get the outcomes that they need. And so that would be one misconception. And the other is that they have to be grid tied. They don't need to. They can run completely islanded. They could be grid independent. And you could have your own grid. You don't need the big grid. So there's instances where the grid is weak or the grid doesn't exist, that a microgrid actually can run continuously and autonomously. So I would say those two.
Okay, if you had to redesign the U.S. grid from scratch, what would you change first?
Well, remember the U.S. grid started as distributed. In San Diego, we have like the gas lamp district because every little district within downtown had its own little power plant. So the grid initially started as completely distributed with a lot of competition. And then it got centralized with the belief that centralization brought more efficiency and lowered costs. And now we're seeing it going back to a decentralized model. So if I was going to redo it from a cybersecurity and resiliency perspective, as I mentioned, the most resilient design is a distributed design. I would have kept it distributed. And when everybody looks at their bill, they see how much of the bill is their transmission and distribution and how much of it is generation. And my guess is the generation is the smallest sliver of the cost and transmission and distribution is the biggest part of that pie. So if that's your biggest cost, the best way to eliminate that cost is to make that as small as possible, which means you put the power as close to where it needs to be consumed. And that way you reduce that big cost. So I would redesign it as distributed, and that distributed generation or that microgrid approach is also the foundation for infrastructure that can address not only the sustainability and resilience we want, but also the scalability that the future needs.
Okay, final closing question. If business leaders listening to this show today could take one action in the next 6 months to prepare for the future of energy, what should they do? What should the decision be?
Do not put the execution and outcome of your business case in the hands of a monopoly that you do not have the traditional vendor supplier relationship with. Do you want the success of your project to be determined by the pace of how well your utility treats you?
Put the power in the hands of the people with microgrids is what you're saying.
It's a credit that, like I said, the future isn't chip constraint; it's energy constraint.
Yeah,
and if your business is going to rely on that, do you really want your execution to be managed and controlled by a monopoly and at the pace at which they wish to support you?
Yeah, that's a great close. Okay, so thanks so much, Adib. I really appreciate it. Learning about you guys is fascinating. I think our listeners will feel the same. And I'm calling here from the ESG worldwide event here in Portland, Oregon, with a lot of leaders from great companies. And the TAO thanks you for your time and look forward to talking to you again.
Thank you. It was great. Appreciate it.
You too. Thank you.
Bye-bye.
That's a wrap on this episode of Techlandia, the podcast, where innovation meets insight. If you enjoyed today's conversation, don't forget to follow us, leave a review, and share it with your fellow tech explorers. You can follow us at techoregon.org for updates and more tech-fueled content. Until next time, stay curious, stay connected, and keep building the future.